Okay, so what I want to demonstrate is IR373, the third Velociraptor project. But to do that, I have to get my Velociraptor running again. So I went back to IR371, and I need to run this command to start it on my Linux machine, because I don't think it's left running. So here's my Linux machine. And presumably if I run that, there we go. It's running Velociraptor. And it tells you that the GUI is ready at this address. So let's see if I can open that address in a browser. I like using Opera for this, just because it's kind of clean. Holy cow, what is all these extra tabs doing here? Let me get rid of all this weird stuff in my Opera. All right. Oh, good. It's working, but of course it doesn't like the fact that it's a self-signed certificate, so I have to approve the exception. And then I need to sign in. I think I remember what I gave it for an administrator. Oops, it's not listening to me. Admin, there we are. Admin and password. There we are. I'm in Velociraptor. Now, let's see if my Windows machine is connected properly. Show all. Oh, it is. Good, good. So I have my Velociraptor Linux server, which I won't have to issue any more commands in, because I'm just going to use the GUI. And I have my Windows machine, and it's got some malware here that we were using in a previous project, which I'm not going to clean off, but it's just left over. And so now we can proceed with the new project, which is 373. And this is just like the others. You put on some fake malware I wrote, and then you detect the evidence with Velociraptor. So I'm going to move this over to the side. And the first thing is going to be infecting the Windows machine, where I just have to carefully follow my steps. Disabling Windows Defender, you don't need to do if you're using my machine, which already has Windows Defender disabled in group policy. So then you install the simulated botnet, which is this thing here. So I copy link address. So I open Internet Explorer is better than Firefox for downloading malware because it's stupider. And so put in that. I think this stuff is probably zipped with a password, so it probably would download successfully even with Firefox. But anyway, Internet Explorer is better. So save that. View downloads. Open folder. Okay. And there it is, security.zip. That's what I've downloaded. So now extract all, extract it with the password malware. Right click, extract all, extract password malware. All right. There we go. And then run bginfo 64 as administrator. This one's a lot easier. I was getting better at writing malware. The previous one had too many steps and it was easy to do it wrong. You just run this as administrator. And when it asks questions, just cancel it here. All right. Or close it. Don't save the changes. I don't care. Okay. That has presumably infected it. And so now we're going to investigate with Velociraptor. This Windows machine should now be infected. And I'm going to move it away because the whole point here, of course, as usual, is you imagine you're at a big company and you got these Windows machines all over the place, and you cannot really get access to the desktop of this Windows machine because it's, in another location far away, and you might have thousands of them. So you use Velociraptor as your central point of incident response to analyze and, in principle, respond to these things, although I've only figured out how to analyze them. The response, I haven't figured out how to get that working inside Velociraptor yet. So the first thing I'm going to do is capture network traffic remotely from the client. So install Wireshark on your Linux machine. I'm not sure I believe that, but anyway, let's go ahead. We're going to do Windows Network Packet Capture. So I go to the client, and then collected, and then plus to get a new artifact, and then I get packet capture. This is actually pretty awesome. Microsoft Windows includes a packet capture utility in the operating system. It's just really hard to use. And Velociraptor has figured out how to use it. This runs, so you have to run this artifact twice. The first time you set the start trace flag to 2, and that will start collecting. Then you run it a second time with false to stop the collecting. And it's actually using some internal, this thing called, creating these ETL Microsoft packet captures in this screwy format. So that's pretty awesome. So go to launch it without changing the parameters. Okay. So I want to run this one now. I launch. And there it is. And I look at the log. Starting query execution, sleeping. Okay. And we'll see. I think it will finish. Let's see the results. Nope, no results. There'll be results when it finishes. All right. Oh, yeah, it's still doing. There it is. Okay. Now, the URL for the pcap.zip. Okay. Running external commands. Oh, it's done with the check mark. Okay, so I can go to results. Okay, and now this is where the packets are being captured into this file with this long path, including temp. So you have to have that path. Copy that. That's the ETL file. And now it says wait a minute. So it's 7:11:54. I'll wait till 7:12:54 because I think my malware only sends a beacon once per minute or something. So you have to collect at least a minute of data. But I guess I can prepare this. You run the same collector again and adjust the parameters. So it's plus packet, Windows packet capture, then configure parameters, and the trace file is the thing I put in a clipboard, that ridiculous long name, and it's uncheck start trace. Okay, and I'm waiting till 54, which is another 15 seconds. Then it's been more than a minute. All right, that should be long enough, so I'll launch it. And there it goes. Doing something. Stopping the trace. So I guess it's netsh trace is the command you're using to do this. And it's making that ETL file, which is some strange Microsoft PCAP format. And now it's collecting the packet capture from the Windows machine and putting it on the Linux machine. Yes. Now it's done. Okay. So now I have that file, and if I go to uploaded files, there it is. A link appears to a PCAP file. Yeah, this is the ETL file in the Microsoft format, which I don't know how to use, but this program converted it into a PCAP file, which I can open in Wireshark. And in my project, I said install Wireshark on Linux, but I don't know why. I'm just going to use it on my host. There's a PCAP file that's going to download it onto my Mac, so I can go here, and I can open the PCAP file from my Mac. And that'll launch it in Wireshark on my Mac. So there we have the PCAPs, and I should be able to find the beacons in here. So do statistics. Let's see, I've got a file, and it's got 700 packets. All right. And so go statistics, conversations. Okay, here's the conversations. And TCP. Okay, that's where it is. And look, now, okay, now they said the traffic. I wonder if I can make this bigger. Does this, that doesn't make it bigger. Anyway, I think I'll zoom in like this. I think people told me that works pretty well. All right, so The traffic to port 8000 is Velociraptor. Port A, port B, here's 3389. That's my RDP. And if there is 8000 anywhere, that would be Velociraptor. The traffic to port 80 is the beacons. Okay. I don't see any traffic to port 80. Oh, there it is. Traffic to port 80. Okay. Right click and apply as filter. Okay. Apply as filter selected. I guess A to B. Okay, good. There we are. Now I've got only a small amount of traffic. I can see it. Neat. This is it. Get report PHP. I recognize that. So now you see the beacons, and now you can follow the TCP stream. Any one of these green ones, right click, follow TCP stream, and now you get the beacon traffic. It sent a GET report.php with an ID number to the server, and the server responded with a page saying report received, and this is a beacon. So anyway, that's pretty cool. So it's infected with malware, it's sending beacons, and I thought this is pretty awesome. You can harvest network captures from the clients in Velociraptor. I thought that was pretty good. And so then you can find the command and control center name with DNS cache. See, since it's been sending traffic off to the command and control server, I could get it from here, by the way. Apply as filter, follow TCP stream. You can see here the name of the server it went to. I guess there it is, host, securityreport.samsclass.info. That's the server it went to, up here, the host. But you can also find that in the DNS cache. And the DNS cache is another useful thing to use because it will show you what names have been used recently. So that's plus DNS. Yep, Windows System DNS cache. This will tell the DNS cache, I think it lasts for 2 minutes. So this will tell you what traffic has been sent, and the beacon is beaconing every minute, so it should always be present in the cache. So it just uses ipconfig to get DNS cache. And I don't think I need to have any parameters. I can just launch it. And there it goes. It's done already. Good. I go to results. And here's, okay, it's been going to Bing. It's been going to Microsoft. And there it is, securityreport.samsclass.info. And here's some kind of Bing going to Azure. Which is kind of nuts. But anyway. All right. And then you can find the exe. So we can make a Yara rule. So let's go. I create a text file containing this rule from the instructions. Let me open my text editor and make a new page and bring this down where you can see it. Okay, so this is a Yara rule. And I think we talked about Yara. Yara can search for any string. So this will look for security report in either ASCII or Microsoft wide characters, 16 bits per either way, and it will just tell us if it finds that in any file. So I save this, save, and I'm going to put it on my desktop and call it ir373.yara, just so I know what it is. All right, and now I can upload that rule with Windows Search Yara. So it's Yara and Windows Search Yara. This will search by a Yara rule. So you configure. On the right side, I can upload my rule. Click the link, and now I can upload a rule. So I click, okay. Wait, here, show all files. Okay, now I can get places like desktop, IR373. Okay, good. And now upload or select up. I see. Yeah, upload. All right. You can upload a binary. Okay, upload. All right. And upload your Yara rule. All right. So I think I've done that. Okay, now parameters. Look for exe files. Okay. So I think just exe is all I need here. And I think the dollars is good. That would put the exe at the end of the file name. And launch the collector. Okay, let's see if this works. I'm not sure if it uploaded my Yara rule or not. That GUI confused me a little. We're going to see what it did. Well, it's doing something. It's not complaining. And I would think if there was no Yara rule, it would complain. So it might be just using some default rule, though. Okay, it's done something. All right, downloading some file. Scanning some file. Okay. Okay, I think what it's doing is scanning all the exe files on the disk to see if any of them contain that security report string. So this might take a little while. Yep, there's 30 seconds. And it's filled up the page. Here's more. That's done. Good. That didn't take too long. Let's see what the results are. Oh, there you go. It found the file. In the downloads folder, securitytest.exe, which is what we got by unzipping that folder, that is the executable that contains this string, security report, which is part of the Command and Control Center domain name. So that's pretty awesome. We found the malware with Yara. And I think there's another one, Sysmon. We can use Sysmon, which is pretty awesome. And you can install Sysmon. Even if the Windows doesn't have Sysmon installed, you can install it. So you go here to Sysmon and internal Sysmon install. This will install it on the client. Now I think it's probably already there, but anyway, this is what you do. I don't think you have to configure any parameters. By default, they will install the configuration from Swift on security, which is a good one. It just ignores a bunch of boring events that are internal to Windows that you don't need to look at, and it works pretty good. So we can just launch this one, and that will install Sysmon on the machine. And there it goes. Removing a temp file, downloading it into a temp file, and then running it from the temp file, which is pretty awesome. So Sysmon will run on the Windows machine and collect event logs, and now we can grab the system event logs with the Windows event logs. Windows event logs EVTX. This will get any kind of event logs you want, and in particular, you can get the Sysmon event logs by going into the parameters and path regex here, you put Sysmon. Now, in order to make it not take forever, I want to restrict it to the last 5 minutes. So this is 2021, 1022. Zulu, it's Zulu time. So now it's 2:23. So I want to pick up at like 2:18, I guess. So it's 2021. Well, 10:22. Okay, and 2:18 a.m. So 2:18. All right, and the end date is 10:22, 2:24. All right. That's a 6-minute period. All right, let's see if that works, because there's many events in the event log, so restricting the time range is just a way to stop it from being too much data and taking forever. It went pretty fast, and it got 18 rows. Good. Not too much data. So let's look at the results. And there are the event logs. And so in here I see this is Sysmon. Okay, and I wonder what I'm looking for here. Well, I'm looking for the command line. And a scheduled task, right. There's a scheduled task that runs every minute. So I should be able to find it, and it should have a SVC host schedule line here, okay? Let's see, and that would be in the parent command line. So here's parent command line. That's not it. That's services. And this is why I only would restrict it to a few minutes, because there's all kinds of things always happening on a Windows machine, and you'll get events from all of them. So parent command line, those are network connections. Well, that's RDP, and that's RDP. Those are remote desktop protocol. That's me. That's not interesting. Well, looks like I did not find the event I expected to find. I'm looking for an event with rule name dash, not RDP. So it looks like I did not succeed in getting the event I need here. Here's rule name dash, sysmon. Yeah, it should have that security in it. In fact, I can use the browser search, Control F. It should have security tests. And it did not find it. Okay, I apparently fouled it up and did not get the scheduled task. So I think I'm going to try again. Let's go. Maybe I'll just give it more than 5 minutes. Windows event logs, EVTX. Windows event logs, EVTX. Path regex. Sysmon. I might have fouled up the dates. So it's 2021, 10/22. And let's just go from 2 to 2:27. That'd be like a half hour. From 2 to 2:30, let's say there. Oh, that's 12:30. Oh, I wonder if I made that mistake before. Oh, I think I did. I think I made the endpoint. No, he still didn't listen to me. Delete, 2. Ah, okay. Now it's 2:02. Delete, 30. Maybe I fouled up the time last time. There, now I got a half hour. Let's launch that. That should give me 99 rows. Okay. And now, am I in the results? Looks like I'm in the results. Okay. And now I'm looking for something with the string security test. Security test, okay? Let's just see. I'm just going to use Control F. Security test. There we are. Okay. So I think that's the event I need. Rule name minus. This is the malware running. Remember, it's in the downloads folder named security test. And you can see here how it ran. You can see that the thing that is running it is a scheduled job, because one of these has that information in it. So here it is running it. And there's one of them that has a parent command line that includes schedule. So we'll just keep looking for security tests. And it's more of a drag than I thought it would be. But searching for security test is good. Let's try searching for schedule. That might get us what we need. And downloading this stuff and putting it in a spreadsheet or something might be a better way to analyze this data than this way. But let's try looking for schedule. Okay, it's not here. And it's not here. Okay. You might have trouble finding this flag. I might have to change my idea of the flag here. Oh. Well, it'll be easy enough to find anyway. I might just change the picture. All right. In fact, I think I'm going to capture the right picture right now. So that schedule thing is harder to find than it should be, but what's pretty easy to find is security test. Let me find an easy one. Security test. Okay. And let's get one on the first page. Okay. So here's one. Security test. Okay. And let's go back to the first occurrence of security tests. Okay. There's an event with security test in it. But I'm going to get this image. Okay. All right, and now the one with security test. There it is. No, it's not. All right. All right. There's the one with security test. Okay. That'll do. Oh. All right, those two pictures are what I'm going to change the flag to. All right. All right, and now let me see, there's another flag defined here, scheduled tasks. So now that we've seen that there was a scheduled task for one of them, then, which didn't appear as much as it should here, then we can look for task scheduler. So that is scheduler, Windows System Task Scheduler. So run this one, and this will tell you the scheduled tasks on the Windows machine. And here are the results. And the beaconing command is going to be this one here, running security test. So you can see it right there. It's running that one. And that's the thing that's making the beacons. So anyway, that's the pretty good deal. And another thing you can do is you can make a hunt, which I'd like to show you. Hunts are what you do after you find some indicators of compromise. Then you want to search through many machines, maybe all your machines, looking for that. So you go here to the 3-bar icon and go to Hunt Manager. And now you can create a hunt with the plus sign. And you can enter a description. And I'm using Detect Security Test Beaconer. That's my description. And now I can select artifacts here. And so I can do these things, sysmon install. Okay. And then I can do evtx, hunter, and then task scheduler, and then DNS cache, all the things we just did. There. At the bottom left, click Configure Parameters, and you see they're all here, all those things. And so now configure the parameters. Sysmon install, the default is fine. evtx hunter, I want it to have IOC regex will be security test. And date after we'll set to a time 5 minutes in the past. So that would be 10:22. It's now 2:34, so I'll make it 2. And I'll make it 2:25. All right, a little bit more than that long in the past. That seemed to work better. All right. And now task scheduler. I've got a task path, and I know what that is now. So I'll put in the right task path. And then DNS cache, I don't need any parameters. So now we're done. We can launch it. And now you select your hunt. And now it's not running yet. So you hit the green arrow. Are you sure you want to run it? I run it. And I think by default it'll run on all my machines. And there's only one machine in my case. But this is what you do. And this is part of the power of Velociraptor. It's asynchronous. So if you had 1,000 machines scattered across different time zones, it would send a request to all of them and then collect the data as it comes back like email. So you don't have to, it doesn't freeze up or anything. And if some of them are down or not working, it just won't report from them. That's the point. This is why this is awesome. Now you can, I found an indicator of compromise, check all the machines and let me see how many of them are infected. All from one central place. I don't need to drive there or get anybody to touch those keyboards or anything. That's the power of this thing. So, that's the game. And I was not able to remediate from Velociraptor though. There's a couple of commands you have to execute to get rid of the malware. And there is a way to get an administrator command prompt in Velociraptor to execute a command on the machines, but I couldn't get it. So if I wanted to remediate for Windows Network, what I would do is I would not use Velociraptor. I would write like a batch file, and then I would deploy it with group policy to run that batch file on the machines. But there's probably some way to do it in Velociraptor. I couldn't figure out how though. And if not yet, they'll probably add that later. Does it tell you what machines don't respond? Yes, I think it does. So when the hunt is done, you'll see, click the hunt's name, and then you click the notebook. And here it gives you all the information it collected. And so at the very least, you have the client IDs here. So you could see which client IDs have not responded yet after a period of time. Download this thing into like a spreadsheet or something, or a database. So here you got all the information. Here it is installing Sysmon, and here it is downloading the event ID. Here's all the events, and on it goes. Here's the DNS cache, including the malicious URL. So this is really nice. This is what we've been talking about all through this course. This is the live collection of a little bit of targeted data, so it's not overwhelming. You have a reasonable amount of data from each machine, and now you can quickly run queries on that with grep or a spreadsheet or a database to find out, which machines have this. Anyway, that's what's great. It doesn't, but this is all it does. It gives you this information, and then you'll have to download it and put it in like a database or something and correlate it with your list of all the machines, which you can get from up here. So that's pretty cool. And that's what I wanted to show you. That's, I think, the really powerful stuff in Velociraptor. So I'm going to stop that recording.